All right, well, we will get started. Couple things quickly. I just handed back your test to you. Sorry about the Chapter 2 test not getting back sooner. I had some people who hadn't taken it yet, and I think at this point they've all dropped the class, so I don't think they're going to be taking it. So I'm like, okay, let's get them back to you. I also apologize. I was kind of laid up this weekend and not feeling quite right, so I did not get your grades put in until yesterday, sometime recently. It was either today or yesterday. So your grades should be up to date now, except for I just finished taking a look at your homework that was due last night. You guys did a really, really good job on it, most of you, so that's really good. I had a lot of problems that everybody got completely right, or most people got almost completely right. So those scores will be really good when we put them in. When I put them in, I'll try and do that probably tomorrow. But I've got them written down already. Schedule for tonight and next week and the following week, just so you kind of know if you haven't checked out the syllabus. Tonight we're covering 3.5 and 3.6. 3.5 is really short. 3.6 also is not too long. So I think we'll get out a little bit early tonight, so that'll be nice. Next week we'll cover 3.7 and 3.8. And then the following week we will have our test over the second part of Chapter 3. And again, it will be kind of a shorter test. So that will be on, let's see, today's the 23rd. Next week is the 30th. And then it'll be like the 6th or whatever that Tuesday is. Okay. So that's what we've got going on here for the next 3 weeks. Now the lunch crew is coming. They all had to stop and get something to eat. And so just to explain one thing, I didn't put a percentage on your most recent test that we took, the short one we took last week, but it was out of 30 points. So what I did is I just converted that to out of 50 points, and that's what went in as your score on Moodle. And then I also added a little, a couple of points to make the highest score in the class 100. So I just added that to everybody. They just kind of shifted everybody's grades up. You know, a vertical shift. We just shifted everybody's grades up that distance, so that made everybody's scores just a little bit better. But so that is where we're at. Okay, so, and like I mentioned, for those of you who just got here, the homework, it looked really, really good when I was checking it out. It looks like most of you who attempted it got almost all of it right that you did. Well, anyway, we'll just leave it at that. So today, we are starting on the two topics we're covering today. 3.5 is talking about real zeros of a polynomial function. And then 3.6 is talking about what are called complex zeros. So we're going to talk about those two things today. We're going to start out with the real zeros. If you have a calculator, you're going to want one before the end of this section. So get that out and handy and ready to go. But the first thing that we have is really just a concept statement. It's called the rational zero theorem. And the rational zero theorem says, if we have this polynomial, and you may remember from last week, polynomial, this is just the generic way we write any polynomial. All these a's, remember, are just numbers. And then we have these x's are raised to a power. Okay, and it can be however long or however short it needs to be. That's why it's so generic. Okay? But if we write a polynomial out in standard form, highest power to lowest power, with integer coefficients, that means no decimals, no fractions for the coefficients. And here's where the important information starts. This is just saying, write it out. Okay. If R is a rational zero, now I want to pause there for a second. Does anybody remember what rational means? When we talk about numbers, not rational when we talk about people. Rational means you can write it as a fraction of two integers. So like 1/2, or even 7, because 7 is 7 over 1, right? So those would be rational numbers. So if R is a rational zero, of the function f, then r is of the form p over q. It can be written as a fraction. Okay? And plus or minus in front of it because it could be positive or negative. Where p, so the top number, is a factor of the constant a sub 0. And we're going to practice several of these. So I know this is a lot of words, and until you see it actually happening, it's hard to figure out what they're saying. So p, the top number, is a factor of the constant, and a sub 0. And q, the denominator of your answer, is a factor of the leading coefficient a sub n. Okay, so I know that's a lot of words, but I'm going to show you how this works and how we do it. Does everybody who wants to have that written down? I know you got a picture. Everybody else have it written down who wants it written down? All right, so let's do an example. Now this example, all we're doing is writing out the possibilities. We are not solving anything yet. We're just going to write down what are the possibilities that could be zeros for this function. Could be rational zeros. Okay, so what we want to do is when they ask this, we want to recognize, okay, if we're looking for a rational zero, we're looking for this idea of it's got to be a fraction, p over q. Okay, we have to be able to write it as a fraction. The top number has to be a factor of the constant. In this case, that's a 3. So it has to be a factor of 3. And we don't care about the sign, the negative 3. It's plus or minus. It doesn't make any difference. Okay? The bottom number, use red. The bottom number has to be a factor of the leading coefficient, which is 2. Okay? So what we're going to do next is we're going to write down the factors of 3 and the factors of 2. I'm going to pause for a second. I know people are writing the equations down, so let me just wait for a second.
So again, if you have any questions whatsoever,
so what are the factors of 3? And remember when we talk about factors, we're saying what divides evenly into 3? And there aren't very many. So what numbers can you think of that divide evenly into 3? 1 and 3. That's it. Okay? So 1 divides evenly into 3, and so does 3. Now in the denominator, we're looking for factors of 2. And what numbers can you think of that divide evenly into 2? Just 1 and 2. Okay. So here's the deal. Here's the part that we got to make sure we get. These are the possible numbers that could be in the numerator on top, and the possible numbers that could be in the denominator on the bottom. So what we do is we have to write down all the combinations of these 4. Okay? So on the top, we might have a 1, and on the bottom, we might have a 1. Right? Then on the top, we might have a 1, and on the bottom, we might have a 2. That makes sense so far? So we've taken care of the 1 over 1 and 1 over 2. Now on the top, we might have a 3 over a 1. And we also might have a 3 over a 2. So those are all of our possible fractions that we have. Now, when we see 1 over 1, we don't write 1 over 1. What do we write? 1. So we could have a 1. This is 1/2. That's fine. What would we write here? That's a 3. And then here, we just write 3/2. The fractions, we just pretty much leave as fractions. We might reduce them, but we just leave them as fractions. Now, the other thing that if you look back in your notes or look back at your pictures or whatever, is r was equal to, and I didn't write it down yet, but r was equal to plus or minus p over q. So all of these options get a plus or minus in front of them. Okay, so here's what this means. Out of all the numbers in the world, and there are a lot of them, only these 8 numbers, positive 1, negative 1, positive 1/2, negative 1/2, positive 3, negative 3, positive 3/2, and negative 3/2, will possibly be rational zeros for this function. Okay? And I'll tell you what I tell my classes in school. This is really, when we get to this, we're really doing guess and check. And in math, we do not like to guess and check, because if you just start randomly picking numbers and sticking them in, how many numbers do you have to choose from? Billions, trillions, more than that even. Okay, so this is basically guess and check, but we've taken all those trillions of numbers and now we're down to just 8. That's how this theorem helps us. So if we have to guess and check, this limits the number of options we have to worry about guessing and checking. Okay, so that's the first one. Just write down what are the possible rational zeros. That's all we were doing on this problem. Just write them out. What are the possibilities? Okay, does that make sense? Because we're going to do that several times tonight. Okay, so we get our answers there, and I have a different order, but it's all the same numbers. Okay, let's go on to another one. Now, this one is written a little bit differently. The question is worded differently. The question says, find all the horizontal intercepts, or X-intercepts, of the function. Now, do we remember that X-intercepts and zeros are really the same thing? But one is talking about values of a function. The other one's talking about points on a graph. Okay, but we do the same thing to find them. They mean the exact same thing, except for the context. So notice this is the one we just did, right? And of course, I just erased all the answers. That was the same function, right? Unless I lost my mind here. Let me double check. Yep, same function. So what are the possibilities? Plus or minus 1, plus or minus 1/2, plus or minus 3, and plus or minus 3/2. Right? Those are the possibilities. Now we're going to check to see which ones work. You remember last week, and you guys all did a really good job on your homework, I said. Let's see if you remember what we did. You remember last week how we checked to see if something was a zero of a function? That? Okay, and I think I know where you're going, and you're correct if I'm understanding what you're saying correctly. What we did is we did synthetic division, and if at the end we had a 0, the remainder was 0, that meant it was a 0 of the function. So what we're going to do is we're going to check these to see if any of them are zeros. Okay? Now, we do have 8 of them, but again, 8 is a lot less than, trillions and trillions of numbers. So let's set this up, and here's what we've got. A little hint. Do you remember how many answers we could have if the degree is 4? How many zeros we could have if the degree is 4? That's how many maximums or minimums. We could actually have 4. So not all of these will work. Okay, but we're going to see which ones maybe do work. Okay. So we're going to put our corner there, and we're going to write down, remember we write down our coefficients, 2, 4, -1, -6, and -3. All right. How many of you really, really love fractions? No one's raising their hand? Okay, so if I'm checking these, I'm kind of the same as you. I don't necessarily want to do the fractions. I'm going to start with the 1s and the 3s, right? Because they're not fractions. So let's take a look at this. And I think 1 is probably the easiest, so I'm going to start with 1. And then what do we do?
Times it by 2.
Not yet. Bring down the 2, yep. And then we multiply 2 times the 1, and we get 2. Add, we get 6. Multiply that, we get 6. Add, we get 5. Multiply, we get 5. Add, we get -1, -1, and -4. So is 1 a 0 of this function? No, because unless the remainder is 0, it's not a 0. So unfortunately, for those of you taking notes, you'll have to rewrite it. What I'm going to do is I'm going to erase this because it didn't work. I can erase it. I've got a whiteboard. Okay? And I know that 1 doesn't work. So then what I do is I go over here and I cross off the 1 and I say, well, that one doesn't work. Okay? And like I say, this is kind of guess and check. We just have to kind of work through what works and what doesn't. So let's try another one. You guys can pick for me. What else do you want to try? Do you want to try the 3, or, I mean, maybe you go fractions. What do you want to try? 3? I wasn't trying to influence you one or the way or the other. I was just asking. I like to let you guys pick. All right, so 3. We bring down the 2. Multiply, we get 6. Add, we get 10. Multiply, we get 30. Add, we get 29. Multiply, we get 87. 81. Okay, I'm going to does it make sense that's not going to work? Right? Because 87 times 3 is going to be something really, really big, and when you add it to negative 3, it's not going to work. So 3 is also gone.
But if the revenue is there.
All right. Let's try another one. Let's try. You want to try 3 over 2? Sure, you're going to fractions right away? Are you trying to test me? 3 over 2. All right. So we bring down the 2. Now, if you need a calculator, that's fine. But 2 times 3 over 2 is just a 3. 7 times 3 over 2 is 10.5. And I'm going to stop there. Because once it turns into a decimal, it will never turn back out of a decimal. And so this one is not going to work. Okay, does that make sense? Once we get a 10.5, once we get any sort of a decimal or fraction, we just stop. Because it's not going to magically turn into a 0. Okay? So that one's gone. We've tried 3. Let's switch to some negatives, maybe. I know we don't necessarily like negatives that much either, but I should probably just look at the answer so we don't guess all night. But let's try -1. Okay? I should have looked at the answers, but I don't remember. Okay. Bring down the 2, and we get -2, right? And then we add, and we get 2 again. And this gives us -2. And we add, and we get -3. Multiply, we get +3. Add, we get -3. +3. And that one works. Yes, we found one. Now remember what we did last week also. When we started factoring and we were breaking it up and factoring as we went, we're not going to go back to the original. We're going to move on from this point, forgetting about that remainder, and we're going to move on to this. Right? So now this one, do you see? You see how these are the same? These two and these two, the groups? Okay? When you see a pattern like that, chances are you're going to be able to factor something pretty nicely. And here's the deal. What would I multiply this by to get this? 1. What would I multiply this by to get this? 1. If that's the same, that's a good sign. Okay? So we already tried 1 and 1 didn't work. Let's try this -1 again, because when you're multiplying by a 1, it's actually usually the opposite of what you're multiplying by. So let's try -1 again. Remember multiplicity, answers can happen more than once. So bring down the 2. Multiply, what do we get? -2. Add, we get 0. So multiply, we get 0. Add, we get -3. Multiply, we get a negative times a negative. You get +3 and 0. Because you're multiplying then adding. So, hey, -1 works again, doesn't it? Okay. Now, how many have we found so far? Kind of 1 and kind of 2, right? It was the same one that happened twice. Now remember, this was x to the 4th. Once we divided once, what was this? X to the 3rd. Once we divide it again, what is this? X to the 2nd. So does this make sense? We now have 2x squared, no x's, and -3, and we're trying to figure out when that equals 0. Does that make sense from here? So this is 2x squared, this is x's, this is constant. Okay? So once we get down to here, and you get down to something squared, we can always solve quadratic. This is a quadratic now. We can always solve this. One option we have is factoring. Another option is a quadratic formula. And in this case, it's even easier than those two because there's only one x in the problem, right? The other one went away. We just have to try and get this x by itself. So how do we start getting that x by itself?
And depending on
Add 3. So 2x squared equals 3, because this cancels out. Then what? Divided by 2.
if a male
And now we have x squared equals 3 over 2. And then what else do we have to do to get rid of that exponent? Take the square root of both sides. Now, do you remember what we have to put in front of that when we take the square root of both sides? A plus and a minus. That's how we get the other two answers, right? X squared should give us 2 answers. So plus and minus. So who has their calculator? What is the square root of 3/2? Or 1.5 is what that is as a decimal. We're going to round this off, and we'll use 3 decimal places again like we have. 1.224. Okay, now we have a positive 1.224, but don't we also have a negative because it's plus or minus? Okay, so we've got all of our x values. These are all the zeros, -1, and those two. But the question actually asked for the intercepts, right? You remember how we write intercepts? The intercepts are where it crosses the x-axis. So it's always going to be an x value, comma, 0. Right? So we write our answer, -1, comma, 0. And that one happens twice, but we only need to write it once. And then we have -1.224, comma, 0. And positive 1.224, comma, 0. And those would be our intercepts. Okay? So, as I mentioned, we don't like to do this in math very often, but every once in a while. Oh, did we round wrong? Should have been 225. Evidently.
Well, it was longer, but I just did 3.
Right, but I mean, is the next number bigger than 5? Or 5 or bigger?
1, 2, 3, 4.
Okay, we should have rounded that up to 225. Does that make sense? Do we remember how to round? Are we okay there? Okay. So these should have been 225s, but you see that we've got the right answers? That's how we do it? Okay. And now I got distracted. But again, we don't like to do this guess and check very often, so we want to be as efficient as possible. There are actually a whole bunch of other rules that we could learn. We're not going to spend a lot of time with other rules because we're just going to take a shot at it. So anyway, that's the example 3. Does that make sense? After we write down the possibilities, we just check them to see what works. Okay? And hopefully we don't have to check for too long until we find one that works. Oh, one other thing. Why are these numbers not in this list? And why is that okay? And here's the reason. These numbers, remember, are only rationals. These numbers down here, when those decimals go on and on and on forever, those are called irrational. So they still work. They're still zeros, but they're not in this list because these are only the rationals. It'd be impossible to list all the irrationals. That could maybe work. So we just list the rationals. Okay? All right. Let's do this one. While I'm erasing, you guys can have a minute to write this down. And the first question I'll ask is, now this one is it's find the zeros, right? Same process, but when we give our answer, we're just going to say x equals whatever. Okay? How many real zeros could we have here? I think I heard somebody say it. There's 3, right? If the degree is 3, that's the most number of zeros you could have. Okay?
If you're not married with children by a certain age, you may feel pressure. What's wrong with you? I don't see.
So let's start out with that process we did on the very first one, P over Q.
30, 35.
Where do our numbers for P come from? The top. Factors of 2. So factors of 2. And let's list them out. What are the factors of 2? 1 and 2. Okay. Then, where does the q come from? Factors of what? What is it? 4? So factors of 4. And what are the factors of 4? 1, and we only have to list the 2 once, but 1, 2, and 4, right? Okay, now when we list them all out, and I don't know why I did it in a weird order last time. I don't usually do it in that order. So usually what I do is 1 over 1 is 1. 2 over 1 is 2, right? Then we have 1 divided by 2 is 1/2. 1 divided by, or 2 divided by 2 is, what's 2 divided by 2? 1. Do I have to write that again? No, I've already got it in my list, so I don't have to write it again. Then 1 divided by 4 is 1/4, and 2 divided by 4 is 1/2. Do I have to write that one again? No, it's already in my list. So even though we had more factors, we still come up with the same. In fact, let me put these up here. We come up with the same number of possibilities. And then what do we have to remember that we need to do? Whoops, that we have to do in front of each of these? It could be plus or minus. So plus or minus 1, plus or minus 2, plus or minus 1/2, plus or minus 1/4. So that's the first step. What are the possibilities? Now we need to check them. So 4, -10, -2, and 2. Okay, do you guys want to know a little shortcut on one of them? Shortcuts are good, right? You don't really have to check 1, except for just look for this hint. So if 1 is going to work, if we add up all these numbers, 4, -10, -2, and 2, if they add up to be 0, 1 will work. If they do not add up to be 0, 1 will not work. Positive 1. So do these add up to be 0? 4 plus -10 plus -2 plus positive 2? No. So I'm not even going to bother checking 1. It's not going to work. If you don't trust me, go ahead and check it, but it's not going to work. You won't hurt my feelings. It's fine. Okay? So let's check something else. What do you think? What do you want to try? 1/4? Okay. Positive? Okay, 1/4. So bring down the 4. 4 times 1/4 is 1. And -10 times, or plus 1 is -9. When we multiply this, we get -9/4. What does that tell me? We can stop, right? As soon as we get a fraction, we can stop, which is really nice, even though we don't like fractions. But once we get a fraction, we get to stop. So positive 1/4 is a no-go. All right, and again, I'm sorry, but I get to erase, and I know you can't. It's good practice for your synthetic division anyway. All right, somebody else pick one for us.
-2.
-2. Let's try it. So bring down the 4. 4 times -2 is -8. Gives us -18. That gives us positive 36. And that's positive 34. And that's -68. And that's not going to work, right? So -2 is gone. -2 is gone. Somebody else pick one. We've crossed off 3. Only 5 more to go. -1/2. You like the fractions. -1/2. You're just trying to see if I can actually do fractions, I think. Okay. So 4. Now 4 times -1/2 is -2. That gives us -12. -12 times -1/2 is positive 6. We add those, we get 4. Uh-oh. I think this one's going to work. 4 times -1/2 is -2. And that gives us 0. Okay, hang on. I got something. There's a hair in my mouth. It's probably mine. It's a white hair. Probably came from my head because I'm old and have white hair now. So anyway. So that one works. Does that make sense? Got a 0, that one works. All of a sudden I start feeling it getting closer and closer to my mouth, and I thought that was a bad thing. So, okay, so -1/2. Now, remember what we've got left. This was x cubed. So what is this? X squared, right? This is an x. So what we have left is 4x squared minus 12x plus 4 equals 0. Does that make sense? Okay. So we've got one of our zeros, -1/2. Once we get down to quadratic, remember we can factor, we can use a quadratic formula, or sometimes we can just solve, but this one has 2 x's, so we can't just solve. So we've got to use factoring or quadratic formula. I'm going to look at this and I'm going to say, we will not be able to factor this. Okay, so our other option is quadratic formula. So now we have to remember the quadratic formula. X equals opposite of b plus or minus, and then inside the radical b squared minus 4ac over 2a. Now one other little shortcut that we can use. Do we see that all of these are divisible by something? 4, 2 and 4, even a bigger number, right? What we can do, because this is an equation, we can divide everything by 4. Remember, if we do the same thing to both sides of an equation, that's okay. So when we divide this by 4, we just get x squared. This divided by 4 will be -3x. This divided by 4 will be 1. And then 0 divided by 4 is still 0. Right? So it just makes all of our numbers smaller, which is really nice. Okay. Now let's identify, before we put this into the equation, what is the a value? 1, the b value, and the c value, 1. Okay. So let's plug it in. X equals opposite of b, which we just said was -3, plus or minus the square root of b, -3 squared, minus 4 times a, which is 1, times c, which is also 1, over 2 times a. So are we okay filling that in? To be honest, unless I know that I can factor it right away, I usually go with quadratic formula. So unless you felt really, really good about the factoring, you may want to just jump to the quadratic formula right away. If you felt really good about the factoring, then try to factor it. Once you get down to quadratic, well, like this one and the last one wouldn't factor. I don't think this one factors either. So once you get down to quadratic, those are your options. You can factor a quadratic formula. So if you're not sure you can factor it, I would probably just jump to the quadratic formula. And once I have it written like this, dividing by 4, then I'm positive we can't factor it, because there's no factors of 1 times 1 that will add it to be 3, right? Because you only have 1. All right, so let's simplify. The opposite of -3 is 3. What is -3 squared? 9, positive 9. And again, you guys, a lot of you can just type this into your calculator, this part under here, but I don't have my calculator here right away. So -4, 4 times 1 times 1 over 2. Okay. So then we've got 3 plus or minus. This will be a 5, right? 9 minus 4 is 5 over 2. Now here's where we have to be careful, because that plus or minus, right, is actually 2 separate answers. And the 2 separate answers are, this means 3 plus the square root of 5 divided by 2. It also means 3 minus the square root of 5 divided by 2. That's what that plus or minus does. It actually means 2 different answers, one adding, one subtracting. So if you're going to do this on a calculator and try and do it all at once, you need to make sure that you put parentheses around your numbers there. Now, if you don't want to do it all at once, that's even better probably at this point. So here's what you're going to do. 3 plus the square root of 5. Hit enter. You might have to do the square root of 5 first and hit enter, and then plus 3. Okay? And then once you get that answer, divide by 2. And what do we get? I should probably get my calculator just to check.
So we are talking with maybe theoretical giving advantage to these things, but the practical.
So 3 plus the square root of 5
That's like basically.
divided by 2.
explanation of the function.
It looks like 2.618. Okay.
Would it be 3 decimals?
Just 3 numbers after the decimal. Yep, that's what we'll kind of do. Unless they tell us to round some other way, we'll just go 3 decimals all the time. Okay. So then, when we go down to this one, we're going to do the same thing. And we're going to go with 3 minus the square root of 5. Oops. And that one looks like we get 0.382. As long as I didn't, whoops, 2. As long as I didn't type it in wrong. Now again, with yours, you'll probably have to do square root of 5 and then change it to a negative and add the 3. And then get that and divide by 2.
Add 3?
Yeah, because the 3 is positive. It's the square root of 5 that's the negative part. So it's weird that you have to change that one to a negative.
What did you get?
3, my writing got crooked there. It's 0.382. You didn't get that? Did anybody else get 0.382, or did I mess up? Okay. So I'm going to hope that that's right. Now, when we say the zero, so I'm going to come and make sure we got that. But when we say the zeros, we just say x equals, x equals, x equals. And remember our 3 of them, -1/2 was 1, and then 2.618 and 382. Oh, 382. All right, everybody else good? All right. Okay, this one, here's another one. Same type of process, finding the real zeros. Oh, I shouldn't have erased that. We'll probably need it again. All right. So let's start out. I'll let you guys copy that down. And actually, if you can't see it very well, it says 3x cubed minus x squared minus 6x and plus 2.
This is the microwave.
Oh. So P over Q, right? Want to figure out what we should try? Where do the numbers for P come from? Factors of 2, this one right here. And let's go ahead and write those down. It's 1 and 2, right? But it hasn't been 2 every time. That's boring. All right. And on the bottom, Q, factors of 3 from right here. And that's just 1 and 3. So when we write down all the different combinations, again, we can say 1 over 1 is 1. 2 over 1 is 2. 1 over 3. And then 2 over 3. Oh, I think maybe the first one we had them switched around. The 3 was on the top, 2 was on the bottom. But we've had 2s every. And then we've got plus or minus for each of these. All right. Are we okay with that process of synthetic division? Just starting to check. Okay. Very quickly, I want to take a look at one of them. Let's see. We got 3 -1, -6, 2. I want you to tell me, is 1 going to work or is 1 not going to work? +1. No, because when we add them up, we don't get 0, right? So 1 is not going to work. And I'm going to jump us, because I happen to know this one actually we could have factored. But it's a harder factor. We'd have had to factor by grouping. So we've done that. We could have done it, but right now we're kind of in guessing and checking mode, right? So let me see just a second. It's going to be, I think 1/3 is going to work. So let's try 1/3. Okay, so we'll just jump to the answer that works right away. You know, I know that's cheating, but whatever. So 3. What is 1/3 times 3? 1. -1 plus 1 is 0. That's nice. 0 times 1/3 is still 0. -6 plus 0 is -6. And -6 times 1/3 is -2, which is really nice because that works out, right? So yes, this is one of our zeros. X equals 1/3. Now, remember what we have left. This was x cubed. We're looking for 3 answers. This is now x squared. 3x squared. No x's. -6 equals 0. Remember what happens here? We can just solve to get the x by itself. So what do we do to get that x by itself? Add 6. Then what? Divide by 3. So x squared equals 2 when we reduce that. And what else would we do? Take the square root of both sides. And we have to put in. Now that one, square root of 2, is not a bad answer, right? That's actually pretty nice. So you may see sometimes that the answer will just stay written as square root of 2 and negative square root of 2 as exact answers. If we wanted to round them off, what would square root of 2 equal? From your calculator, 3 decimal places. Sorry? 414? So 1.414. And then this one is just the same, but opposite, negative 1.414. Does that make sense? Was everybody able to get that same answer? I think I have just the exact ones on here for this one. Yeah, because they came out nicely, so we just left them as plus or minus square root of 2. Okay, so again, degree is 3. We have 3 zeros, right? That makes sense? All right. How are we feeling about that? Yeah. Round it off. And read the directions because each one is a little bit different. They're different. Sometimes, like we said, sometimes they have you write the intercepts, so then you write it as ordered pairs, something comma 0. Sometimes they'll probably say round it off. I think actually, if I remember right, I think they always accept the rounded off version, so that's fine if you want to do that every time. But I think also if you leave it exact, they'll accept that. Okay, so how are we feeling about writing down the possibilities and then checking them out and finding the answer? Are we getting there a little bit? Yeah.
I have a question on something else that was in your list.
Okay.
Why is there no x of the 6 in the interest rate?
This one? Okay. So what happens here is you got your x squared right here, right? And then this next one is the x's, and the next one is the constant. So it's because this one, it's 0 times x, that just goes away. So it's really because we're skipping that place value kind of. Does that make sense? On the last one, we had a number there, so it was still something and then something else. But if you ever get a 0, that term just goes away. Okay? And that's it for the first one. Like I said, that one was fairly short, right? Are we feeling okay about that? Okay? Now, there are only 6 problems, but they might have multiple parts, so just make sure that you do your practice, before you just jump right into that. and what, if you need some reminders, watch the video and stuff. But 6 questions on that. So any questions before we take a little break?